Okay, everything is back up and running. Here we go again with another stream. So under the hood, I've renamed the project to VK Paint, which is also what you will see in the repository, VK Paint. And today I'm going to experiment with stroke drawing. So I am done with the debug marker stuff, and they are pretty much working, except for one thing that I've noticed this morning, which is that I'm getting this error from the validation layer, which is about terms to call, but is required an extension VKX to debug report, which has not been enabled. That is weird because I'm pretty sure VKX to debug marker. Is this VKX debug marker? And that should be enabled. Debug marker, it is required. So maybe we need to enable that from the instance initialization. So we can extend the debug report, which is exactly this one. And let's see if moving it up in here when the initialization happening changes anything. Okay, extension not present, so that is not even present in the instance as an extension. So I'm wondering what could even cause this mismatching. So instance extension size should get the right size. What does it mean it is not enabled? Let's see if there's anything up here missing. So yes, there is indeed something up here. Okay, missing extension required by device extension debug marker. Missing extension. All required extension for each extension. Device create enabled extension names. And I'm pretty sure that is what I'm currently doing. But let me get back to the initialization, and I think it's time to collapse some of these functions that I'm not working on at the moment. So during the device finding and we get to create it, right? So enabled layers, and that's one thing. Enabled extensions count, and the extensions, right? And the features. So that's not about features. It says that missing extension required by the device extension VK debug marker. Missing extension required by the extension debug marker. Okay, so yeah, too many debug in the same line. So I'm enabling the debug marker but not the debug report, which is not that one. So vkxt debug report name extension. Okay, this should fix, and I'm even wondering how did it happen to work. Good, now it's all good except is not. What is going on? So we are getting report debug report. Let's see, we are getting an extension not present, and I'm wondering whether this extension should be enabled here. Okay, let's try again. Not this feature. I hate edit and continue, and I should likely stop that from happening. So options, edit and continue, debugging, enable edit and continue. I hate it. I just hate it. Might be useful sometimes, but not at this time. And that was it. Okay, so in a sane environment, I should probably check whether these extensions are even supported. I mean, if they even exist in the current hardware. But not gonna do that now. What I want to do is instead go to the debugging stuff and change the behavior of these functions to either do nothing or just check whether the function even exists. So does it exist? If not, and here is where I should null point to them. And if it doesn't, then return whatever default, which cannot happen. Let's see if there is any vk result extension not present. Well, that might be something. Or just return vk success. Yeah, and since this one is a void, we can just if it, and this will likely silence any complaints. If we are not in debug mode, we don't want any debug to interfere with the performance we are trying to get, right? And they will also likely not get even initialized because that is not even called. And again, let's get back to this extension here and disable it when we are not in a debug mode. So enough fixing. Time to get back to our main issue today, which is drawing samples. In one of my previous streams, it was about multi-threading, and what I did is to decouple the application, the window run loop, which is in here, which only has to do the final render to the swap chain, whether while drawing on the canvas is performed by another thread, which is the render thread, which is not really the best name for it. And so we could rename it to be the canvas render thread, which should better explain it. And just to be clean, I'm gonna clean up the repo by saying fix debug extensions and that's done. We are back to a clean state where we can start planning what we want to do. So as I said in one of the earlier streams, I've implemented the input routing, which is just going to call the mouse events on the virtual function that is then implemented in the drawing application class. And at this point we can start to work on our logic, which is to grab the mouse pressed state and to so let's declare a boolean which will keep track of the click state. So what we want to do is to start our logic by linking the mouse down and up to the mouse move event. So what we want to do is the drag state, which is false at the beginning, and the drag state will be set to true whenever the mouse is down gets called, and drag gets back to false whenever we are back to an up state. And meanwhile, focusing on the good. And I'm back with some freshly made chamomilla, which is not fresh, it's very hot, but it's a hand-picked chamomilla with some 0 kilometers honey, which is made here by a local farmer. How is it called? Farmer? The people that harvest the honey. Okay, it's always a good habit to drink something warm while streaming. It's good for the voice, because I'm not used to talk this much. Actually, I'm not used to talk at all. So let's get back to our input logic. And what we want to do is to set the capture for this window. Okay, maybe instead of doing it in here, we can do it right here when the Windows logic happens. So set capture basically captures mouse events even when the cursor is outside of the window, so it just keeps track of it. Set or release capture right from this thread. I guess it's linked to the thread itself. Alright, so that being done, it was just a little detail, and now we want to check if we are in drag mode. If drag, which means that we can start to keep track of our drawing, and from this point we want to start so drag is true, but we also want to record what is the initial position of the cursor, so whenever the mouse moves we are ready to draw something. We will first check if the distance is greater than 1. And then for each step in the space we want to draw a line that is exactly 1 pixel distant from the other one. I'm checking the distance because apparently the mouse move events comes even if the mouse haven't moved a whole pixel yet. And I'm not sure whether that happens because of something else that generates the event, but I don't care right now. So at this point we want to generate a command that will then be consumed by the render thread. Okay, and we want to store a position, a cue, so I want to get a stood double-ended cue, or we can we can either create a structure. Yes, we should. So struct and let's call it sample, which is a sample that needs to be drawn. So it's a sample, stroke sample, and contains an IVAC2, which is the cursor, and that's it for now. We can then extend it later to have pressures or other data. And we want a structure that a queue that is filled with samples. Strokes queue. Okay. And at this point we want to have that header as well. So include the queue Okay. And we also want to rename this to be canvas render thread. Strokes Q. To mutex, we also need to synchronize the access to this Q. Stroke mutex. What the hell? Mutex and condition variable, stroke condition variable, because we want to have this thread to be sleeping while it has nothing else to do. So after we've made sure everything has got to that point, we come in here and do a wait. Instead wait. Wait, is it? No. Let's strokes. Yeah, first we need a unique lock. Unique lock for that mutex. Okay, and then we can go to the queue. No, first the CV. Strokes, stroke. There are some mismatches, so just a stroke. Stroke mutex, stroke Q. Here back to the stroke condition variable, and let's do a wait. Wait until. No, not until. Just a regular wait with a predicate. Okay. So wait on this unique lock, and here is the tricky part, that every damn time gets my brain to explode. Standard condition variable wait. Okay. So the predicate returns false if the wait should be continued, which is the single sentence that I really hate. So return false if we should continue to wait. So we wanted to wait. So here's a lambda which captures everything by ref and returns false. So returns false if we want to keep waiting. So we want to keep waiting as long as the queue is empty or we have stopped running And we are running, so if we are still running and the stroke queue is empty, return false, otherwise return true. So it's that simple that I'm not able to express it directly. So this would end up being something else, but yeah, who cares? I mean, this way returns false. So let me just write return false. Okay. Let me expand this. So if is still running and the queue is empty, right, return false, which means keep waiting, right? Otherwise return true. Okay, this makes much more sense. And down here we should think of the result. So if we stopped because it's not running anymore, that means that we haven't got anything in this queue, and so we must stop here the thread, which means we are done. Okay. Next. The next step is to convert for ref sample in strokes in the queue. So let's see. Do we really want it to be a queue? Don't think I even need a queue, because a vector should be good enough, since I'm not picking one of them at a time. Instead, I'm just going through all of them once they are ready to be rendered. Okay, cool. Okay, let me get, whoops, let me get this and bring it down here, because this one is not going to be reused, or is it? I'm thinking, I mean, we should never have more than 1,000, should we? Well, I will think about that later, because if we have more strokes, then more samples than the commands itself, then that is going to be a problem. And at this point I'm not even sure whether we need to create new commands, or it is better to use the one that I've already created. So basically that is my own pool, right, of 1,000 of them. And at this point, let's make that simpler. And we will do a regular for I from 0 to strokes, what the hell? Strokes strokes Q, which is not a Q anymore, so let me call that samples, stroke samples dot size, increment that, and maybe we want to do a std max of these. So the max of strokes.size, just a simple check so we don't go over the boundary of the vector, because we are going to access it directly in here. In samples count okay, we've got the number of samples, and we can use that data down in here. So we may only end up using a subset of our pool of commands. Okay, still running. And at this point we can say that we are going to not care about the color, but we are playing around with the translation. Okay. And that translation comes directly from the mouse. So that translation comes from the X of the mouse. But since we want to get something faster, let me say that the current position and revert this. The current position will be given by the samples I dot cursor dot x divided, so our theta float theta will be that divided by size swap chain extent dot width. So let's get that number from 0 to 1 and multiply it by glm pi. Do we have 2 pi? We have 2 pi, which we need as a float. Okay, so we've got the angle, that is the location in the normalized x position of the mouse with respect to the current window. And so all we need to do is to generate that data. So as we get here, we want to create a new stroke sample, and that has a cursor which is not the current position, but let's say we have a float t which is the lerp from the old position and the new position. No, that which is not the so the point we are looking for is somewhere between the first and the last position, and that in between is given by a float of the current index divided by the distance. Okay, so this will give us a smooth transition from point A to B, which we can then given that we have got our lock guard in place, right? So we've got our mutex locked, and we can now say that we want to go to the stroke symbol and push back our new sample. That as easy as that. And before I forget about it, we also want to stroke samples and clear that out. As a note, keep the samples that did not get processed. If it ever happens that samples count is bigger, it's smaller than stroke sample, and we can also express that by asserting we want to assert that samples count is equal to stroke samples dot size. Okay, let's assert that. Cool. Now it's the moment to try to compile it, and it seems like it is compiling. And we get nothing on screen. Fair enough. Yeah, I didn't click, but now I'm clicking and we still got nothing on screen. Let's see what is going on. Starting from the mouse position. So drag is true. Does this happen at all? Yes, it happens. It will set drag to true. Okay. We get a few samples and then get the lock. All right, we need at this point we also need to strokes CV to notify the canvas render thread. Otherwise it will never get the chance to wake up, and that is bad. we're getting something, which is good. At least the gears are moving. We have a few strokes samples. And the samples are only 5. Why? Oh, it's not 5, it's actually 5 hex, which is still 5 indeed. Oh, damn. Yeah, not max, but mean. We don't want the bigger of them, just the smallest, so we don't get out of bound. Okay, we are getting something. And we just ended up filling the whole vector. And that's because we are limited to 100 of strokes commands. And with 1000 we should be alright. Let's try that again. What? 1000? Yeah. Well, let's just ignore at the moment. That may happen because when I go out of the window or do something strange, it will complain. Okay, we are getting something, but that is black, likely because we never initialized the color. Okay, we can fix that by uncommenting the code. So we are definitely drawing something, but it's not moving. For some reason it doesn't like. Okay. And why is that? That is likely because we probably giving it something empty. Stanno vomitando. È tutto vomitoso.
Ah, non mi sono accorta.
Una parte.
Rapporto vomitoso. Ma dai, l'ho appena messo pulito. Omar, c'è un problema. La finestra che dà sul terrazzo quadrato non tiene. Entra tutta la terra continuamente. Puoi attaccarci quegli affari lì che hai comprato?
Non sono abbastanza.
Almeno sotto, per far sì che non entri la terra. Cioè, non posso continuare a pulire terra.
Ma fuori?
È fuori sporco perché c'è il vento.
Beh, allora bisognerebbe partire da fuori.
Ho capito, l'ho fatto i giorni scorsi, ma ogni giorno c'è vento, quindi se non pulisco durante la notte, di giorno c'è la terra. Ecco, se ci fosse qualcosa che fa in modo che la terra non entri in casa sarebbe...
Un po' di tè?
Sì, grazie di ciuffare. Lui non cresce niente. Che tè?
E te? Camomilla, non è te.
La camomilla della Federica.
Sì. Con dentro il limone. Però la potevi vedere da sola. Sembrano i tuoi commenti di notte. Guarda che bisogna cambiarlo, eh. Ah, anche fame,
Vabbè, tu non ti muovi, dormi continuamente.
Ho capito.
Ho per mezz'ora io cercavo la forza di alzarmi, tu non rispondevi neanche. Cioè, io almeno mi sveglio.
Sì, ma anch'io ero sveglio.
Però non rispondi, sembri morto, ti tocco, sei gelido, un cadavere nel letto.
Vabbè, ma cosa c'entra? Sono in stand-by.
Sì.
Devi agitarlo un po' come il mouse. Vabbè. Fine dello streaming. Lerp. To that position. I did this. Ehi. Chi c'è? Ehi. Un po' di tè? Buono il tè di papà. Allora, ascolta bene, eh? Listen me, kid. Oh. Show. Oh, vomitando. Tutto vomitoso, come mai? Ok. Passato?
Mia mamma ha detto che ha litigato con mio papà.
Okay, so we are definitely getting something. And one last thing that we need to do here is to fix the termination, because we have to unlock the thread, otherwise it will never finish joining it. Okay. All that thing again. Yes. Do you want to turn on filter keys? No, brief. Nope. Thanks. Yeah. Just see out. I have the suspect that the command's initializations really take a lot of time. Canvas ready. And let's see how long it takes to compute all the validation and stuff. Okay, so that's why I couldn't see much until now. Okay, that makes sense. So this is all the time we are saving by not creating them every time. So yeah, we are painting really fast. It looks so smooth. Cool.